Hello, everybody. So I'm going to give you a little bit background about myself. So I've been working on speech recognition and NLP for 15 years, something like that. And until 2011, I was one of the weird guys because I was working on all this amazing stuff and it was not working. And in 2011, the deep learning started to appear in speech recognition, and then I became one of the cool guys because I'm working on deep learning. And a friend of mine told me yesterday that, hey, you are not working on speech and NLP, you're working on AI. So and right now I'm an AI expert. So a little bit, I'm working at Spoken. So Spoken, it's a company that is based in Seattle. And what we are offering cloud infrastructure. We are putting, for customer service, their cloud. We are providing cloud solutions for customer service. We have our own data centers, so we have 6 data centers in 4 different continents. We have more than 150 patents. And this is the interesting part because I work in data. So there is tons of data that is coming through our system. So right now, we are recording around 100,000 hours a day of speech. And in 2017, we are going to record 500,000 of conversation hours. We have billions of screen captures, agent screen captures that we are recording, and tens of millions of user interaction. So I want to talk about AI in the context of conversations. So basically, what does it mean? So everybody knows or some of you know what is a man-machine interface. You have some kind of human being. You have some kind of a machine that can be Amazon Alexa, Apple Siri, some kind of a chatbot that people think that it's going to change the world. And the person is interacting with the machine. He can interact through voice or through text. But most of our interaction is not with machines. We are interacting with each other. So think about it. 90% of the times we're interacting with other human beings. So I'm thinking about, we have a human over here, you have a human over here, and let's put some kind of an AI that will understand what's going on in the conversation. Okay, so what does it mean? Think about it is that conference calls. Okay, so I assume that some of you are thinking that when you're having a conference call, you're thinking, hey, that's a good usage of my time. And the reason that 90% of the conference call doesn't work because nobody wants to be that guy that takes the notes. Nobody wants to be that guy that sends all the summarization and to do the follow-ups. So think about it, if you had some kind of an AI system that do all of this for us. Okay? Another example is I'm thinking about a person is coming to the doctor. Okay? So right now, 80% of the time the doctor is just need to document everything and to create, to do some kind of information retrieval from his brain what's going on. So think about it, if you had some kind of an AI system that listens to the conversation at real time, create some kind of recommendations and questions to the doctor and what's being on, I think that will be game-changing for us. So what type of examples can we think about? So I told you about conference calls. For our use case, we are talking about contact centers. So we want, to create some kind of an AI that will assist, contact center agents to perform better. And I'm not talking about, the simple use case. We are talking about actual AI. So what is the goal in terms of, conversation AI? Well, the goal is, first of all, to understand how humans interact. Okay, because we as human, it's very complicated for us to understand how, to teach machines how to interact. Want to get insights about the conversation. We can do summarization. We can do, for example, to discuss trends, some kind of a sentiment. This is the easy stuff. But we can do much more than that in terms of AI. And the final goal is that if we want to build machines that better interact with humans, so we need to understand how people interact with each other. Because that right now it's very complicated. So if we're talking, I talked really in the high level right now. So let's think about it. How we can classify, you are a data scientist, so you're thinking about classification, so this is a good example. So how we can discuss, about conversation AI in a more detailed example. So think about it, is that we can classify it as something like a passive system versus an active system. So a passive system, the conversation is already ended, and we are trying, to get some insights. So we are talking about offline algorithms. We can talk about, doing some summarization, getting some insights, getting some sentiment, creating some kind of, a big information and, create some kind of a knowledge-based construction of that. And an active system is any system that works in an online mechanism, meaning that it does intervention in the call, and it performs, machine learning algorithms in online. So the difference between passive and active is also from the algorithmic level and from the system level, it's enormous. The second thing that we can think about is microanalysis versus macroanalysis. When I'm talking about microanalysis, I'm talking about understanding a single conversation. For example, if I'm talking with a friend in a conference, so microanalysis will be understanding a single interaction between two human beings, versus a macroanalysis will be, I want to get the big picture. So if I'm talking about a macroanalysis, I want to understand what are all the conversation in the conference. So the difference in the type of algorithms is, when I'm talking about microanalysis, I need that my algorithms will be very, very accurate. If I'm talking about sentiment analysis, I want very good sentiment analysis. But if I'm talking about macroanalysis, so I want just to understand the big picture. So the conceptual thinking is different. So, of course, every type of use case of conversation AI can be divided into these 4 categories, and we create some kind of a matrix that will understand what's going on over there. So I want to talk about, this is, a deep learning session, so I want to talk about the technology behind it. So one of the reasons, and one of the issues that I want to understand, and I want you also to understand, is the impact of deep learning in these type of technologies. So I've been working on deep learning, I think, for 4 years, 5 years, because I'm a speech recognition guy originally. So I can divide, the deep learning impact of, these kind of technologies, especially speech recognition and NLP, into 3 divisions, into 3 parts. We can discuss about before 2011, where I can tell you from my experience that it was not working really well. Most of the algorithms were really complicated, advanced statistical machine learning algorithms, but it was not working so well. And because of that, there were not a lot of applications. And basically, it was not moving in the right direction. But then something really interesting happened in 2011. The first application of deep learning was for speech recognition, and it was groundbreaking. How influenced it was be? It was around 30 to 40% word error rate reduction, meaning that's enormous. So that is why if you are talking to your Google Voice or to Siri, it's actually working. Okay? And the big companies understand that this technology is actually working, so they started to promote it. So we saw a lot of applications. We saw Apple Siri, we saw Microsoft Cortana, we saw Google Now, we saw Amazon Alexa. And in 2015, people understand that deep learning is everything needs to be done with deep learning. So right now they are investigating new type of techniques, how to optimize all these algorithms, because one of the problems which I'm facing right now is how we can scale up these algorithms. So because conversation AI is involved with a lot of technologies, I want to discuss on a specific use case. I want to discuss about speech recognition and the aspect of in terms of conversation AI, because think about it. People are talking to each other. So the first thing they need to do is to create some kind of a very powerful speech recognition. So the first question is why speech recognition is so complicated. And I can tell you from experience, because my team, we are working on speech recognition, we are working on NLP, we are working on computer vision, we are working on general deep learning stuff. So speech recognition is by far the most complicated system. And the reason for that, we can divide it into 2 parts. First of all, the system and the algorithms are very, very complicated, because we are talking about high performance computing. We are talking about bleeding edge deep learning algorithms, all these buzzwords, if you are probably familiar with LSTMs, BLSTMs, recursive neural networks, all of these, mumbo jumbo words are appearing in these type of technologies. And the second is the application in the noise. And right now, I cannot build a system that can recognize all the languages in the world. In fact, if you'll see, I think that Google and I think Microsoft offer around between 80 to 100 languages. And in the world, there are around 8,000 languages that people speak. So think about it, in terms of speech recognition, we are covering less than 2% of the world languages. And the reason that it's still in ongoing research. Another thing is that once you have noise in opposed to images, the system doesn't work so well. If I'm talking from a closed microphone everything works perfectly fine. But if I'm talking from a distance, for example, 3 or 4 meters from the system, everything collapses. So that's a huge problem, and it's still in ongoing research. So how does a speech recognition system build? I'm not going to give you a lot of details about speech recognition because I don't want to be too much technical. But we can divide it to 3 parts. So assuming that you have some kind of a signal. So the first part is what we call the signal level. We are trying to extract speech from the signal because there might be a lot of other things in the signal. There might be music, there might be other noises. So we just want to extract the speech. And this is a complicated system. It's not too trivial. Believe me, I'm working on that. The second part, I want to extract features like every machine learning task. And then comes the things that are related to speech recognition. We have the acoustic level when you are trying to create from these features different type of sounds. Okay? And then we assume that people are speaking. They're not producing arbitrary sounds. So we are combining these sounds into words and into sentences. And everything over here is involved with deep learning. And one question is how entangled deep learning and speech recognition. And again, the answer is they're entangled a lot. So I just want to give you examples of how many different algorithms we are using in the system. So if you are talking about speech extraction, this is fairly, I just want to extract a speech. So right now we are applying deep neural network in 2016. People are applying deep neural networks in order to extract the speech from that because we have a lot of noise in the signal. In the features, people are exploring things like representation learning or automatic feature learning. If you are talking about the acoustic and language, so everything, as you can see, everything is surrounded over deep learning. We have, you can see all the nice words in deep learning, LSTMs. I'm not going to discuss about technical stuff, but just think how many different algorithms there are in the system. And basically, in the bleeding edge speech recognition systems, you have 6 or 7 different deep learning methodologies that you need to incorporate if you want to have a very good speech recognition system. So how does me as working at Spoken, we fit into this picture? And the reason is that Spoken provides some cloud infrastructure for customer service. So it's very natural for us to provide all this conversation AI. Because think about it, we have customers on the one side, we have agents on the other side, we provide the platform, and it's very natural for us to provide this AI. But one of the problems is that we are collecting tons of data. When I'm talking about tons of data, I'm aiming for 500,000 hours a day of conversation hours. So I need to take all these amazing algorithms, hope that they will work, and create some kind of a very scalable system to do that. So there are a few questions. So first of all, is 500,000 hours of conversation a day a realistic number? And the answer is yes. If you're talking about 500,000 hours of conversation, we are talking about analyzing around 60,000 agents. That's not a big number. There are millions and millions of customer service agents all around the world. So 60,000 agents, just a fraction of this number. And when we are talking about 500,000 hours of conversation, it's actually a bigger number because it's 1 million hours. Because I need to analyze, the agent channel and the user channel. So basically, I need to analyze 2 channels. So if my math is right, so I'm talking about 1 million hours of speech. Think about it, that's an enormous number. How big it is? Well, it's quite a big number. So think about it, 1 hour of speech is around 60 megabytes. So 1 million hours of speech is around 60 terabytes. So if maybe the infrastructure guys will say, well, that's a nice number, but it's not a big number. So that's a huge number because I need to run all my deep learning algorithms on this data in a day, and I need to run it in real time. Okay, so I'm talking about 18 petabytes of data a year. So that's a massive scaling problem. So the big question is that can me as an engineer or whatever can do 1 million hours a day? And it all boils down to how much it's going to cost me, assuming that I can provide the technology. So let's talk about the cost. So if we're talking about 1 million hours, let's assume that we are talking about the system needs to work 10 hours a day because I need a real-time system. Nobody cares, nobody talking during midnight. So I need to process, assuming that I'm discarding of peak levels and things like that, I'm talking about 100,000 hours in a single system hour. Okay, so I need to create a system that is 100,000 times more than real time. So we did some experiments, okay? So we took some kind of a very bleeding edge network that is called BLSTM, just called bidirectional LSTM, bidirectional long short-term memory. And we applied and we tried to evaluate how many cores, because everything boils down to how many cores do I need. And we needed 2 cores to process a single call, meaning that I need 200,000 cores to run this BLSTM network. That's a lot. So we did another experiment. We took some kind of a recursive neural network with 25 million parameters. For me, it's, I don't know, because I'm a deep learner, so 25 million parameters for me it's a small number, but I understood that in terms of machine learning, that's a big number. And we got, we got a single core, a single core was able to process, a single core. But again, we are talking about 100,000 cores. Think about it, 100,000 cores, if, it's around $20 million in investment at least. And if I'm talking about AWS services or some kind of a cloud service, I'm talking about $10 million in investment in a year. So my CFO is not happy about this slide. So the big question is that can we do better? And we can try, okay? So what type of things we can do? So we can divide it into 3 parts. We can talk about the algorithms. And when we are talking about the algorithms, we can do some kind of a network in deep learning techniques that are called network optimization or model cloning. In late 2015, early 2016, there are new techniques that are called frame subsampling, that are related to speech recognition. In terms of reducing the data, if we can build better algorithms to extract the speech better, so of course we can do better than that. And HPC refers to high performance computing, I work a lot on HPC, so we can do a lot of optimizations in terms of GPUs, all these libraries like BLAST, Atlas, software optimization, and we can try. And the key question is that were we able to do that? And the answer is yes. We were able to accelerate the system by a factor of 35. We invested a lot of time into that, and eventually we understand that a factor of 35 means a factor of 35 reduction in cost of the hardware, meaning that I can build a scalable system that processes 1 million hours of speech in less than $600,000 of hardware. So I think that's impressive. And I can tell that I manage a team that I think that some of them are the world experts in deep learning for speech and NLP. And on a personal level, I think that I'm honored to work with these guys, and I think that they are doing an amazing job. So thank you very much.